Hello everyone, I'm Frank and welcome to Frank Puzzles, and this is today's challenging level puzzle, and it's called Romeo's Tint by Secret Santa. And here are the rules. We have normal Sudoku rules apply, which means in every cell in the grid, place a single digit from 1 through 9 such that there are no repeats in any row, column, or designated 9-cell region. We have Tetris, where we need to put non-overlapping tetromino pieces into the grid. Every piece touches the bottom of the grid or shares an edge with a plate piece below it. That is, there are no floating pieces. So every piece touches the bottom of the grid, or it shares an edge with a piece below it. So a tetromino piece is basically a piece that is made up of 4 cells, all of which are orthogonally connected together as a region. Which means you can go from any cell in the tetromino piece to any other cell in the tetromino piece just by going through edges. So this is a valid tetromino piece. This, however, is not, because it's not going through. You can't go from this cell to any other cell in the tetromino piece by just going through edges, all while staying within the region. So this is an example of a tetromino piece that does not work, and it's made up of 4 cells, all of which must be orthogonally connected. And that, again, to be orthogonally connected, it just means that you can go from any cell in the region to any other cell in the region just by going through edges while staying within the tetromino piece. In addition, this has to basically be able to either share an edge with the bottom of the grid, or it shares an edge with the piece below it. So you could have something like this, where this piece touches the bottom of the grid, and this piece is sharing an edge with another tetromino piece, just like basically Tetris. So where you can't have it just basically do something like this, right? This is not allowed because this is just floating in air. We need to actually place the piece down as in Tetris. Pieces of the same shape, regardless of reflection or rotation, may not share an edge. So this is actually not valid here because these are the same piece, rotated and reflected, right? If you rotate this 90 degrees and then you reflect it, then it's exactly the same piece, which is not allowed. So they cannot be touching each other, or they cannot be sharing an edge if they are the exact same piece, including rotation and reflection. So this is actually not valid here. You could have something like, though, say this. This would be valid because these are not the same piece if you rotate or reflect it even. So that's how Tetris works. We have silent pieces, where within a piece, orthogonally adjacent digits must differ by 5 or more. So otherwise known as whisper, which is why they are silent pieces. So for example, say this was a 3. This would have to be an 8 or 9, because those are the only digits which are 5 or more away from 3. And that's an example of how silent pieces work. We have quads, where 4 cells touching a circle, the 4 cells touching a circle must include the indicated pieces in any rotation or reflection. So this is actually valid because this quad here, quad circle, says in one of the 4 cells surrounding this quad, you have to have one that's part of a piece that looks like an L, whether rotated or reflected. So this is basically an L. It's L if you take it that way, if you look at it that way. And then you How would you rotate it? And then you reflect it. And then it would match the piece that we have, right? So that's an example of how these quad circles work. And finally, we have crop key dots, where digits separated by a black dot are in a 1:2 ratio. Not all dots are given. So for example, if this were, say, a 2, this would have to be a 1 or a 4 to maintain the 1:2 ratio between them. And those are all the rules. If you'd like to play along, there's going to be a link in the description. And now, I'm going to get started. Let's go. Okay, so we have to determine where these Tetris pieces are. I guess we start at the bottom. So here we have one piece that's going to be something that's going to be an N shaped or an S shape or a Z shape in some sort of rotation or reflection. And we also have an L or a J. This has to be a square. So either there's a square here, or square here. If it's square here, the problem is, oh, I guess it could. You could have the T being there. If you have a square here, okay, so you can never have a square here, because if you had a square here, the problem is you would have to have a square somewhere here, and then you'd have two squares touching each other, which is not allowed, because no piece of the same shape may share an edge. So it's either going to be here, but how does that work? Say you had a square here. You have to have then a square being over here, but then the problem is if you have a square, you can't have a square being here. If there's a square here, then that blocks off the T shape from being ever in one of these 4 cells. So this cannot be a square, so the square has to be here. So this must be a square. We have to have a T shape with it, so it has to go like that. This is a square. This is in a 1:2 ratio. How does that work? I don't think that can work. Oh, okay, so, okay. Right, so, okay, you can't have a square here. You can have then a square here, or a square here. If we try to have a square here, that also doesn't work, because then you have a T here. That's the only way it can fit. But the problem is that this T would then have a 1:2 ratio, which has a difference of 5 because of the silent piece rule. But there's no 2 digits which can be 5 apart from each other, which are also in a 1:2 ratio with each other. So that's not possible. So that can't work. Therefore, we must have a square either here or here. If we have it here, there's no way you can get a T to fit here. So then it has to be this way. So this must be orange, and this must be the T. Next to that, this has to be orange here, because we need an orange in one of these cells. This must be green for that. So this is, I guess we can use dark. So these are the Tetris blocks right now. Again, you can't have Tetris block going this way, because if it did, that would be a 1:2 ratio with a difference of 5, which again, you don't have 2 digits satisfying that, right? 5 and 10 is in a 1:2 ratio and has a difference of 5, but 10 is obviously not a digit, so it must go then this way. For that shape, we have to have 2 cells here, at least. So this cell, if they're all purple, that doesn't work. You could, if you have all green, that doesn't work. So that means this is empty. So we need one here, which means that goes this way. Let's mark that. And then we have another one going here. So if it goes 2 this way, it has to go that way then, right? Because there's no other way possible. And if we try to have an L then, I guess it could do this. That's possible. So it could do something like that. So we're guaranteed these two are part of the shape. That means this must be part of a different shape. And if it's all that, that has to go that way. If it could go like that. So this could go that way too. What happens if we try that then? That kind of works. Yeah, that works. So let's see. We need one here and one here, but we don't know which way this goes. One interesting thing here. Guess that could be the same. Oh, no, it cannot be this. So if we tried to do this, the problem is this doesn't form as a valid piece, right? You can't have the S shape here. So it cannot do that. So it must be a different, well, I guess it could do something like that. Right? You could have something like that and then that there. That kind of works. Or something like this, right? That works. Ah, that's one interesting aspect I didn't think about. Obviously, these are 5 away from each other, but they all have to be 5 away from another digit, guaranteed. So, what digit cannot appear in these silent pieces? It must be 5, right? 5 cannot appear in any of these silent pieces, because if it did, the problem is that it would be 5 away from another digit, which is not possible, because if you subtract 5 or more from 5, you get 0 or less. If you get 5, add more 5 or more to 5, you get 10 or more. And those are obviously don't work. So in box 9, the 5 has to be here. Where is the 5 then in box 8? It has to be here. So therefore, this must go out this way. So this must go out this way, which means this cannot be the S shape. It has to be the L shaped. So this is the L shape here. This is S shape here. So it must go like that. This has to go out here as the T shape, because there's no other place for it. So this is a shape here. This is a shape here. This is a shape here. And then this must be part of the pink here. We don't know where it goes there. So where's 5 in box 7? It can't be here because of 5 in the column or row there, so therefore it must be here. And this couldn't be 5 because of 5 in the row. So that's another reason why that didn't work. So this has to go, both of these have to be connected, right? Well, no, it could go this way. It can never go this, well, it could go that way. Oh, but again, if you try to go this way, that doesn't work because you have 2 digits in the same region being in a 1-to-2 ratio, which means they have to have a difference of 5, which is not allowed. So it cannot go this way. It can't go this way. So I think that guarantees that there's a cell there, right? The remaining possible places you can have, so you have this being a corner, cannot go that way because that would go too far. Can't go this way because of the 1 to 2 ratio here. Could go this, let's see. So we have the singleton. So singleton cannot go that way. Could go that way. That's possible. Can't go this way because of the 1 to 2 ratio. This is done too, so that's not allowed. Because it goes too far. Then can go that way. Can't go that way, and that's it. And so those are the possibilities for this as a small part. You could go here. You could go here. That's pretty much it. Can't be the middle part of the L, and could be the end part. If it goes that way, or that way. Those all work. Oh, so no, we don't know that. Okay. We need something that's long. Okay, maybe let's try filling out what these digits can be. These are in, these can have to be next to 2 digits is 5 or more away from, so it cannot be 4 or 6. Oh, these have to be 2 or more away from the digits that are away from 5 or 6. So it's 1, 2, 3, 7, 8, 9 there. We need a 4 and a 6 here. This is next to 2 unique digits at least. That has to be 5 or more away from. And these must be... So one of these is 4 or 6. That means this is also 4 or 6. So we have 4 or 6 here, which is next to 1 or 9. And that's different from the other 1 or 9, which must be next to one of these being 4 or 6. Okay, so we'll mark these. This is going to be the gray one. Oh, this can't be 9. So this has to be 1. So this is 1, this is 6, which makes this 9. 1 is in a 1 to 2 ratio with 2. 1 has to be next to 7, 8, or 9 here. Or it could be 6. 6, 7, 8, 9, and this is 2, 3, or 4. Well, this digit is next to 2 unique digits for the silent piece, which are 5 or more away. So this has to be 2, 3, or 4. 9 with 4 is one of these. So that means this must be for high digits, 7 and 8. And we have 1 and 2 next to it, right? Yeah, because it has both of the low digits have to be 5 or more away from 7 and 8. So again, 7 can't be here. If we had 1 here, that would force us to be 2, so that cannot be 2. This is 2, 8, and that forces this to be a 4 here. And this must be a 3, 4 pair. We don't know which. You have 2 or 8 here, which means this digit is the opposite, so it cannot... it's the same set. So in whisper 5 lines, or silent pieces, anytime you have digits which have to be 5 or more away from each other, you always alternate between low digits and high digits. And the reason why is what digits can next be, and the low digits being 1 through 4, the high digits being 6 through 9. What digits can be next to a low digit? 1 can be next to 6 through 9, 2 can be next to 7 through 9, 3 can be next to 8 or 9, and 4 can only be next to 9, all of which are high digits. So you'll always alternate between low and high digits when you have a difference of 5 between digits. So this is the same set as this, so that can't be 2 or 8. It's 1 or 7. This is 3 or 4. This must be 1, 3, or 4 here because of the 2 in the column. This cannot be 2 and 4. It also cannot be 4 and 8. It can't be 1 or 2. This must be a 3, 6 pair. which eliminates 3 and 6 in the rest of the box. These are next to 2 unique digits, which are 5 away or more away from it. So 6 cannot be here, 6 cannot be here because of a 3-6 pair, so this must be 6 here. Therefore, one of these is guaranteed to be a 6 here. We're not sure which. So one of those is guaranteed to be 6. Either 6 is here, which makes 1 there and 1 there. Or we have a 6 here, which makes 1 there. So one of these is a 1. Four. Where is 4 in box 8? Cannot be in these cells, which are orthogonally next to 2 unique digits, which they must be 5 or more away from. So it has to be one of these 2. So one of these 2 is 4. So if this were 4, this would have to be 9, but it can't be 9 because of the 9 in the row. So this must be 4 here. So that's 4, which makes that 9, which means this has to be 6, which makes that 1. So 1 eliminates 1 from being here. This is a 3-4 pair, which eliminates 3 and 4 in the rest of the row. So that means this must be 2 here. And this is 7 or 8 with 7 or 8 here. 9 has to be next to 2, 3, or 4. Cannot be 4 because it's next to 2 unique digits on the silent piece. So it's 2 or 3, which is next to 7 or 8 here. Which leaves this digit as a 4 here. 4 has to be next to 9 on a silent piece, so this is 9. This can't be 1 or 2 or 4, so that makes this 3. And this must be 1 or 2 here. To be next to a silent piece, or a high digit on the silent piece. 3 eliminates 3 here, so this is 6, which makes this 3. Aha! And there we find... Wait, we have too many 7/8s. That doesn't work. Dang it. Oh. Oh, that's bad. That's bad. That doesn't work. Why doesn't it work? Do I have the piece geometries misset? Maybe. Oh, that's not good. We might have to redo this because I don't know if the geometry is correct. Let's start. Okay. Can it be... Okay, so it cannot be a full square here because then there is no T cell which is part of this. So if we have a square here, the T has to be this way, guaranteed. And then you'd have 2 digits in a 1-to-2 ratio with a difference of 5, which doesn't work. So it cannot be here. So we know one of these... So this has to be orange, right? And if we try to have orange there, how do we get a T piece here? We can't, right? That doesn't, it's too, it has to go like that, right? Which is blocked. Can't go like that, it's blocked. Can't go like that, it's blocked. So it has to be orange there. So that's guaranteed. That means we have to have T going here. And then yellow has to be here. Or sorry, orange has to be here. So that's still guaranteed. So this has to have a piece next to an S shape, so it has to go there. It cannot go this way because of the same problem. So because of the 1-to-2 ratio and also having a difference of 5. So that doesn't work. This is guaranteed to be 5. This cannot go this way because then we don't have 2 pieces here, which are the L or the S piece. So this must go this way. This has to go here. We need a 5 in this box, so there has to be 5 that way. So this must go this way. So this has to go this way, and this must go this way. Well, if it has to go the full amount, then it has to go pink. This has to be the L. This must be green. And it has to go there. Because it cannot be part of 5. So then it must go here. T can only be part of this. This must be 5 here. We have to have, again, 4 or 6. This is next to 2 unique digits, so that can't be 4 or 6. These are next to 2 unique digits in the silent pieces, so it cannot be 4 or 6. 4 or 6 would have to be one of them here. It cannot both be here, because then that would force this to be 1 and 9 at the same time, which is not possible. And again, this can't be 9, so this must be 1, which makes that 2. That's 6. This has to be then one of these is 4, which makes this 9 here. The high digits here then must be 7 and 8. This is 3 and 4. 7 and 8 next to 3 and... So 1, 2, 7, 8. This cannot be 1 because that would force this to be 2. This is again 7, 8, or 9. 2, 3, or 4. If we had 1 here, that would force 2 to be there, which is not possible. If we had, the 7 can never be next to a black crop key dot because 7 halved is 3.5. 7 doubled is 14. Therefore, this can't be 2 or 8. It's 1 or 7. This is then 3 or 4, 3 or 4. We have 1, 3, or 4 here because it can't be 2, because 2 in the column. This cannot be 2 and 4. No 1 and 2. No 4 and 8, so it's 3, 6 as a pair, which means this can't be 6 here. 6 cannot be here. 6 cannot be next to 2 unique digits, so this must be 6 here. Whereas 4 could be here. That was the mistake. Okay, so then we know this can't be 4 and 9. So if we tried 6, that was the mistake. If we tried 6 and 1 here... Right. So if we had 6, 1, that makes this 2, which makes that 3, 4, 3, 4. This would be 7, 8, 7, 8. The problem is 4 would then have to be here. So 4 can never be here. 4 can never be any of these, so 4 has to be one of these two. 4 can't be here because it would be next to a 9, which would be guaranteed. So then if 4 cannot be either of these, then this must be 4 here. So this is 4, which makes this 3, which makes that 4. And that's how we get around it. So that's 4. 3 cannot be here. 3 has to be one of these two. So this must be 3 with 8 and 9. That means 7 has to be one of these two. And it's with 1 or 2. So we have 1 or 2 also here. But obviously 2 cannot be either of these. This is 3, 6 as a pair. 4 cannot be either of these. This can't be 4. Again, we tried to have 6 here. That makes this 1. And you have 2. Oh, wait, but that could... Okay. One of these is 6. Okay, remaining digits in row 9 are 1, 2, 7, 8. Okay. This could be any combination, right? So you either, again, have a 6 here. Where can 4 be? 4 cannot be here. So 4 has to be one of these two. Yeah, we tried to have the 4 here. That doesn't work because that forces 4, 9. This can't be 4, so 4 would have to be here. So again, let's show why the 4 doesn't work there. So 4 doesn't work here because 9 has to be there. If 4 is here, that's 9. This must be then 6 and 1 because there has to be a 6 somewhere in row 8. That makes this 2. This can't be 1 here. This 4 would eliminate 4 here, so that's 3. 4, 3. This would have to be 7, 8 as a pair, but then this would have to be 7 or 8, and we'd have 3 cells requiring 7 or 8 in box 7. right? This would have to be 9 next to 1, 2, or 3. Actually, 2 or 3, which would be next to 7 or 8, and that would be a contradiction. That's why we were running into the problem. I was thinking that the problem was geometry. It's not. It's that I placed a 4 here, and 4 obviously can't be here when 4 has to be here. So that's 4, 3, and 4. This then becomes 1, 2, 7, 8. Obviously no 8 here. This must be 3, 8, and 9 with 1 or 2 here. 2 cannot be here. This is 1, 2, or 7. 7 has to be guaranteed to one of those two cells. 6 has to be one of these two cells here. So if this is 6, this is obviously 1. If this is 6, then this must be 1. So 1 has to be one of these two cells, so 1 cannot be any of these. 4 has to be one of these two cells. So, right. We have to have a 3 somewhere. So if this is 6, this is 1. If this is 6, that's 1. This is 7 or 8, and that's 2. Right? 6, 1, 7 or 8, 2. Which would force this to be 7. 1 or 2. Okay, so let's go through the possibilities. If this is 6, so we have 6 here, this has to be 1. This is 7 or 8, that's 2. This is 7 or 8. This has to be 7. This can't be 1, so that would be 2. This cannot be 7, 8 as a pair, so this would have to be 9, and we have 3, 4, 3, 4 here. That's possible. Right. If this is 6, we have 6 here, that's 1 and 1, so this must be 7 next to 2. And then this would have to be 8. And then we'd have a contradiction, because where would the 1 be in row 9? It would have to be here. But then we'd have a 1 and a 6 here already in this box, so that's not allowed. So it cannot be 6 here. It has to be 6 here. So this is 6, this is 1, that's 2, that's 7. 2 cannot be here. 7 is next to 1 or 2, but it can't be 1, so this is 2. 2 has to be next to 7, 8, or 9, but 7, 8 as a pair is here, so this can't be 7 or 8. It's 9, which forces this to be 3 or 4. 3 or 4 can be next to 8 or 9, which can be, and this is 2 and 8 have to be next to 4. So since this is low, it must be 3 here. This has to be 1, 2, or 4. We don't know which. This 3 eliminates 3 here, so that's 4, which makes this 3. 3 eliminates 3 here, so it's 6 and 3. And we have the same problem, right? That this L-shaped cannot go through here because it would necessarily be 6 and 1 here. So that's not allowed. So it has to go this way. And this is a border. And since this is a border, well, it could go something like that. That is possible. So it has to go either this way, or this way. So either way, this is a border here. We have to have a 5 somewhere in row 6 and cannot be in the silent pieces. So it has to be here. So this is 5. This has to be a high digit. So it must be 7, 8, or 9. Cannot be 9 because of 9 in the column. So it's 7 or 8. Which means this would have to be low. 1, 2, or 4. Can't be 4. 1 or 2. The problem is, if we tried to go further this way, it doesn't work. Because then we have 7, 8, and 9 counted for. This would have to be high and would be 6. Actually, I guess it could be 6 and 1. That is possible. Oh, it cannot go this way because then these would not be difference of 5 away from each other. So it has to go that way, which means this must be 6 because it can't be 7, 8, or 9 because of the 7, 8 pair and the 9 in the column. So this is 6 and it must be next to 1 and 1. So this would be 1 and 1 there. So that's done as a region. This obviously can't be pink. This is not part of a pink cell. You could do something like that, potentially. 3 eliminates 3 from being here. This 1 eliminates 1 from being here. It's 2 or 4. This... We need remaining digits in column 3 are 3, 4, and 5. It could be something like that. That's not possible because we don't have enough low digits here, right? We need to have the 2 highs and 2 lows guaranteed on this I shape. Cannot obviously be full there. Can't be there because that just hovers. So if we try to have a vertical I shape, the only vertical I shape that works is here, but that would be too many. Right, sorry. There would not be okay, let's just show. If this has to be 2, 5, 7, 8, or 9. This obviously can't be 8 because of 8 in the row. But if we try to have a I shape here, we have to have 2 lows and 2 highs. We only have 1 low available, so that's not possible. So therefore, the I shape must be horizontal. It must go like this way, here, or here. We know these two then have to be part of it. So this must be 8 and 3, which eliminates 3 in the rest of the box. If it goes to here, it's 9. So remaining digits in column 4 then. So we know this is edge here. Remaining digits in column 4 are 4 and 9. This 4 eliminates 4 here, so that's 2, which eliminates 2 here, so that's 4. 4 must be then 5 away from 9. That eliminates 9 in the rest of the box, so this must be 2, 5, 7, or 8. Cannot be 5 because of 5 in the column. This 9 eliminates 9 here, so it's 7 or 8. 2 eliminates 2 here. So then we have to have a 2 be in one of these spots here. 3 and 9 eliminate 3 and 9 in the rest of the row. So this is 1, 8 as a pair, which eliminates 1, 8 in the rest of the box and row. So this cannot be 1 or 8. It must be 7. 7, and this can't be 8. It's 2. So 7 is 5 away from 1 and 2, which forces this to be 8 here. 7 eliminates 7 here, so that's 8, which makes this 7. Makes that 8, which makes that 7. So that eliminates 7 in the rest of the box. And 2 cannot be here because of 2 in the row. This cannot be 5 because of the 4, 5 pair in the box. Remaining digits in column 1, we have 1, 2, 6, and 8. Okay. Cannot be 8 here because of 8 in the row. Remaining digits So this cannot be a pink. So the pink has to be either one of these three cells here. Okay. Obviously cannot be part of this. Pink cannot be any part of this. So pink could be, it cannot go, so if this were pink, it cannot be part of here. It can't go here. It can't go here. So the pink would have to do something like that. I guess that's possible. You could have something like that too, potentially, or that. Let's just look at remaining digits. Remaining digits in box 5, we have 4, 7, 8, 9. 4 obviously can't be any of these. 4 cannot be here, so this must be 4 here. So these can never be part of then the same pink piece because they're all high digits. So that means this can't be part of pink because then it can only escape there, but then they would not be 5 away from each other. Remaining digits actually in row 5 are 5 through 9. No 8 here because of 8 in the box. No 6 or 9 here because of 6 or 9 in the column. No 5 here because of 5 in the column. So this has the same problem. This, if it tries to, it cannot exit out this way. Can't go there because that's not 5 difference away. This can't be 5 difference, so that doesn't work. So this must be the pink here. So it goes either this way or that way or whatever. It cannot hover. This cannot be. What could there be a shape here that supports this? The answer, I think, is no, right? If we try to have a shape that supports it, what could it be? T, but then these two would not be 5 away from each other. You can't have an S because we have an S here, and they cannot be they cannot share an edge. So what other shapes are there? I don't think there are any, right? It cannot go here because this is not 5 away from each other. So it would have to be here, and it just doesn't work. Can't be a full flat line because these can't be 5 away from each other. This can't go here, essentially. So, we can't go something like that. We can't do something like that. So this has to be supported by something else. It has to go this way then. So it goes that way, then up. And I think it's the only way that works. Which means this cannot be a full 4 that way, so it has to go there. So then this is a boundary here, and this has to be a 9. That eliminates 9 in the rest of the box. Could go here or here. 7, 8, or 9. This is low, so this must be 3, which means this can't be 7. It's 8 or 9. 3 is next to 8 and 9, only on in a silent piece. This can't be 8 because of 8 in the box, so this is 9, which makes this 8. That eliminates 9 from being here, so this can't be 5. This has to be 6 or 7. The 6, 7 pair eliminates 6, 7 in the rest of the box. So this can't be 6 or 7. It's 5. This can no longer be 8 here. This 8 eliminates 8 here, so that's 2, which makes this 5, which makes this 8. This 6 eliminates 6 here, so it's 7, which makes that 6. 8 has to be next to 1, 2, or 3 here. Cannot be 2, so this is 1 or 3. This 8 eliminates 8 here. So this is 1, which makes this 8. 1 is next to 8 and 9, so that's 8 and 9 there, so that's 3 there. 9 eliminates 9 here, so it's 7 and 9. 1 eliminates 1 here, so it's... Oh, we have a contradiction. Ooh, oh, it doesn't have to go that way. It can go this way. Ooh. How does that work then? Okay, so... I think that's still the same, right? So it doesn't have to go this way. Okay. So we have to be here because otherwise it doesn't, there's nothing underneath it that can work. So then we found a contradiction there, right? Because if this has to be 3 as a low, guaranteed. It's next to 8 or 9. This is 9. This has to be 8. Makes this 2, 5, 8, 7. This is 6. This is 5. 8 eliminates 8 here, so it's 1, which makes this 8, which makes this 9 and 3. This can't be 9. That's 7 and 9. If we have a low here, that would be 3, but we have an or 3 already there, so that's not, that would be contradictory. So it has to be here, and it has to be a 4. But we no longer have an L shape here. We need something in between this. Interesting. So this can't be L, this can't be L. L could be one of these two. We could have it being full that way. Anyways, what are the remaining digits in column 5? We have 1, 2, 7. Remaining digits in column 6. We have 3, 5, and 6. This can't be 3 because of 3 in the row. Remaining digits in column 7, we have 2, 7, 8. Remaining digits in column 9. Sorry, column 8, we have 5 and 6. Ooh, that's interesting. Remaining digits in column 9 are 1, 3, and 9. Can't be 3 because of 3 in the row. This can't be 8 because of 8 in the row. I think it, well, This cannot be part of a, okay, so let's color gray the parts which are not part of a tetromino. This can't be. These can't be. This can't be because it's 4. It would have to be next to a 9. This obviously can't be. 8 would have to go next to the 5, which is not possible. You could have... Okay, so this is 2, which eliminates 2 in the rest of the column. This 8 eliminates 8 in the rest of the column. Okay. You can't... 2 would have to go next to 1 or 6, so that's not possible. This is obviously not pink. I'm thinking that it probably goes that way, right? The full set here cannot be all Tetris pieces because we have a 5 guaranteed. Obviously none of these can be the L because then they would be sharing an edge with another L. If it's here, there's no, okay. These two cannot be connected to each other. Obviously, if they're connected, this would be 6, and that would be 2 or 7, which is not possible then. So these cannot be connected. How would you have something like this then? So say we had... Oh, the L still has to be one of these two. I guess it could be something like that. But to have something like this, So what we're assuming is that it cannot be just here, right? If it actually, ooh, this is 6, can't be 6 and 1. How does this work? This is 1, 6, and 8, right? Because this can't be 1 and 6. So this can never be part of a Tetris. Ooh. We could do something like this. In fact, we sort of have to, or something like that. Okay. This can't be part of it, so it cannot be the full one there. So then this does have to be blue, which forces this to be 9. So this is 9, which makes this 1. That makes this 6. So that makes that 5. This cannot be 1 here, then. It's 2 or 7. So this cannot be here, so this must be full blue there. And this must be 2. So this is 2, this is 7. No longer have 2 available here or here. It's 1 or 7. If we tried to have pink there, that doesn't work because it would be on this cell, and it would... How could it... Well, I guess it could do that. Anyways, 7 eliminates 7 here. This can't be 5. If this went 3 this way, the problem is it's either 3, which would not be next to 8 and 9, or it's 6. So assuming that this is basically pink, it has to go this way, because it can't or share an edge with another pink cell. So then it would have to go this way again, and then this would have to be... It can't be 2 and 6, it has to be 8, 3, but then this can't be 9. So that doesn't work. So this is not a pink cell, so this must be the pink cell here. And it cannot go that way because then it would be hovering, so it has to go this way. And then again, it cannot go full 3 there, so it must go full there. 4 obviously can't be between 2 unique digits, so therefore it must be 9 there. 9 eliminates 9 here, so this can't be 9. This then can't be 6. So 4 can't be next to 2 unique digits on a silent piece, so this is 9, that's 4. This must be 1 then, which must make that 6. 1 eliminates 1 here, so it's 7 and 3. 6 eliminates 6 here, so it's 5 and 6. 7 eliminates 7 here, so it's 2 and 7. 2 eliminates 2 here, so it's 8 and 2. Oops. 8 and 2. 4 eliminates 4 here, so it's 5. 8 eliminates 8 here, so it's 1 and 8. This can't be 9, so it's 3, which forces this to be 9. And we're kind of curious about where the other Tetris pieces are. So I made some pretty bad assumptions here, but it's not too bad. This can't be 5 or more away from that, so this is not a Tetris piece. No, that doesn't work. That doesn't work. Yeah. So 8 doesn't have... it would be floating if it were doing that. 8 cannot be connected to here, so it would have to be connected to there, but then this square doesn't work. So none of these are Tetris pieces. You can't have an L there, so obviously that doesn't work. Could you have a T? Nope. You can't have an L because they would be sharing an edge. So this is failed. Can't be square here. Cannot be T, cannot be T. So all of these are just normal. Interesting. Very cool concept. I like the idea of the whole Tetris pieces. I'm just not very good at it. I made too many bad assumptions here. But it's still solvable fairly easily, I guess. Even if you make bad assumptions. Because you will run into a problem otherwise. Sometime you guaranteed will run into a problem otherwise if you can't find that. So, anyways, I hope you enjoyed this solve, and I'll see you next time on Frank Puzzles. Take care.